Let n equal 34 times 64 times 63 times 270. What is the ratio of the sum of the odd divisors of n to the sum of the even divisors of n? We start off this problem by taking the prime factorization of n. This ends up being 2 cubed times 3 to the 5th times 5 times 7 times 17 squared. We notice that we want to break this down into odd divisors, the sum of them, to the sum of the even divisors. To start this off, we realize that for the odd divisors, they cannot contain any power of 2. So that leaves us with 3 to the 5th times 5 times 7 times 17 squared. So the sum of the odd divisors is just going to be basically the sum of the divisors of this number here. Let's call that a number x. Let's now take a look at the even divisors. The even divisors will have to contain at least one power of 2. So that's either going to be 2, 2 squared, or 2 cubed. And followed by that is going to be any combination of 3 to the 5th times 5 times 7 times 17 squared. So to find the sum of the even divisors, we realize that it's just going to be the sum of all the divisors of this number here, multiplied by 2, multiplied by 2 squared, and multiplied by 2 cubed. That is just going to give us 2 times x plus 2 squared times x plus 2 cubed times x, which equals 2 plus 4 plus 8 times x, giving us 14x. So our left-hand side is x in a ratio to 14x. If we cancel out x from both sides of the equation, we are left with 1 to 14. And that is going to be our final answer, which is answer choice C.